Hello everyone, welcome back to RC Circuits. This is lecture number 5. So in previous lectures, we have mostly discussed the first order circuits, which are maybe RC circuits or RL circuits, and we have drawn the waveforms also for voltage across the capacitor or current through the inductor or any voltage in the circuit. And also we have written the mathematical equation of the waveform. But when we are writing the mathematical equation of the waveform, that includes we have to do some kind of shifting of the waveform, right? So we have discussed briefly about right shift or left shift in time domain. So in this lecture, I am going to discuss mainly about time shifting of the waveform, so which was confusing for some of the students. So I want to clarify in this lecture, and also I want to discuss some more first order RC or RL circuits. So we will start now. So what is the concept of time shifting? The time shifting might be the left shift or right shift. So how do we incorporate that time shift in our equations? So we will show some examples now, and we will go back with our previous equations, and we will incorporate this shifting there. So let's take one simple waveform in time domain. Yes, this is a simple linear equation which is y is equal to t. So at t is equal to 0, the y-axis value is 1, and at t is equal to 1, y is 1. Now if you do right shift of this waveform, let's say 2 units. So we shifted this waveform by 2 units. Then how do we write this equation? So at t is equal to 0, but here the y-axis values did not change, but the time axis is changed. I mean, so at t is equal to 2, now we are getting 0, and at t is equal to 3, we have to get 1, because if you shift this 1 unit, the same shift was happening here also. So if you take this difference, so from 0 to 1, then we have the magnitude increased by 1 unit. Similarly, from 2 to 3, we have 1 unit difference in time, which is 1 unit shift in the y-axis value. So at t is equal to 2, y is 0. At t is equal to 3, y should be 1. So this is what we have to get now. So to get this, what we have to do is y is equal to t minus 2. So if you see here, if you substitute t is equal to 2, then you will get y is equal to 1, and if you substitute t is equal to 3, you will get y is equal to 1. At 2 you will get y is equal to 0, and at 3 you will get y is equal to 1. So this is what the right shift means. So you know the existing waveform equation, which is y is equal to t. If you do right shift, then you will get this equation, which is t minus 2. So simply right shift means replace t with t minus shifted value. I am saying t shift, that is the right shift. And for left shift, you have to replace t with t plus t shift. So if you look at the left shifted waveform, then it looks like this. Now if you substitute t is equal to -2, then you have to get y value as 0, which means y is equal to t plus 2 is our new equation. So see, substitute t is equal to -2, you will get 0, and substitute t is equal to -1, you will get 1. So just simply if you want to left shift, then replace t with t plus the shifted value. So this is as simple as this, but we are dealing with mostly unit step functions and ramp functions, right? So this is ramp function. So if you look at unit step function, then how do we write the mathematical expression? So for unit step functions, so this is u of t, right? Let's say this is y and this is t. So y is equal to u of t, looks like this. So u of t definition is, it is a unit step function. So it is 1 for t greater than 0 and 0 elsewhere. It's okay, t greater than or equal to 0, that we will talk about later. So if you do right shift by t1 units, it looks like this. So this is 1, this is 1, so by t1 t. So this should be y is equal to u of t minus t1. So this is right shift. And similarly, so this one will continue forever till t tends to infinity for all t greater than t1. And if you do left shift, then it looks like this. So it starts at, let's say, minus t1, and it will continue till t tends to infinity. So this is y is equal to u of t plus t1, which is 1 for t greater than or equal to minus t1 and 0 else. So this is how the unit step function looks like. Now let's say we have this kind of graph, a rectangular graph. Then how do you write the mathematical form of this graph? So this magnitude is 1, and let's say this is t1 and this is t2, where t2 is greater than t1. Now see, we know this, right? Let's say from t1 till t tends to infinity, this is u of t minus t1, because it is left shifted by t1 units. Yeah, so keep this aside. So, and also we know we also know, if the graph is there from t2, till t tends to infinity, then this is u of t minus t1 and this is u of t minus t2. If you want to get this rectangular function, then from this graph what you have to do, if you have given these two graphs, then you simply have to subtract, right? So here it is 0. So if you do subtraction, then you will get from t1 to t2 you will get 1. So after t2 it is 1, it is 1. So if you subtract, then you will get 0. So you will get the graph only from t1 to t2. So if you do that, then you will get this waveform only. So this is nothing but u of t minus t1 minus u of t minus t2. This is how the equation looks like for this, as simple as that. And logically, or if you want any, let's say, shortcut, then see, this is starting from t1, right? So you just have to write, and this is unit step function from t1 until t1 it is 0. So you have to write u of t minus t1 because it is right shifted. Then after that, if you keep this continuously, then this 1 will go on till t tends to infinity, but we don't want that. At t2 this has to become 0. It means you need to subtract the magnitude from t2. So this is what we are doing there also. Instead of taking separate graphs every time, so from this graph only you have to simply write u of t minus t1. So from t2 we are getting 0. It means you have to subtract from t2. So minus u of t minus t2. So this is some way to remember. And let's see one more example. Let's say we have exponential graph here, and it is there till infinity. Let's say this equation is, so if you remember, this is the charging voltage of the capacitor. This is voltage across the capacitor, right? So from some initial value to some final value it is charging. So this equation looks like, let's say the final value is v infinity. So v infinity times 1 minus e power minus t by tau, because initial value is 0. This is 0. But and e power minus t by tau u of t. This is in general if it is starting from 0. But you have this kind of graph. Let's say this is t1. It means it is right shifted by t1, right? So in place of t you have to substitute t minus t1. So if you want to represent this in mathematical form, so you have to simply write minus of t minus t1 by tau u of t minus t1. So this is the mathematical expression for this graph. Now let's say I have the similar graph, but it is not going till t tends to infinity. Let's say I am making it 0 immediately at t2. So this is v infinity and this is t1. So how do you write this equation? So we know this equation, right? It is just right shifted equation of v infinity times 1 minus e power minus t by 2 u of t. So replace, so it is starting from t1, which means you have to write in place of t minus t1. So 1 minus e power minus t minus t1 by tau u of t minus t1. If you leave this equation here, then you will get this, right? But it is going to 0 at t2, which means you have to make this magnitude as 0, which means you have to subtract the magnitude of v infinity from t2. I am saying if you subtract this graph from this graph, let's say this is from t2 and the magnitude is v infinity, then you will get this, right? Which means you have to subtract the unit step function with the magnitude of v infinity from t2. So this is a unit step function. You have to subtract this one, v infinity u of t minus t2. So this is how this equation looks like. So, and let's say we will take one more example. We have this equation, and this is going till t tends to infinity. So this is simple. We know this equation, right, from 0, which is v infinity times 1 minus e power minus t by tau. Now I am doing left shifting of that waveform, which means you have to replace, in place of t, replace with t plus t1. So you will get v infinity times 1 minus e power minus t plus t1 by tau u of t plus t1. So this is that equation. Now let's say I have the same graph, but it is going to 0 at t is equal to 0. So, and this is stopped here. It is going to 0 at t is equal to 0. Now how do we write this equation? You have to, so you know this equation. Now you just have to subtract the magnitude of v infinity from t greater than 0. Then you will get this equation, right? So v infinity times 1 minus e power minus t plus t1 by tau u of t plus t1 minus v infinity is the magnitude, and you have to subtract the unit step function from t greater than 0. So it is simply u of t. So this is how the equation looks like, and I think this is enough for our solutions. So if you look at the previous examples, see, this is going till t tends to infinity. So you know this equation, so you just have to left shift this by t1, then you will get that equation. So this is fine. And look at this equation. We have 80 into 1 minus e power minus t by tau, which is, so yeah, here it is. This is 80 into 1 minus e power minus t by tau if it is charging from t is equal to 0. But we are applying signal way before t is equal to 0. So I am assuming it as at t1 we have applied 100 volts. So it starts charging from t1 and it is charged till 5 time constants and it is staying at 80. So if you left shift this one, then you will get this kind of equation, right? And it will go till t tends to infinity, because this is going till t tends to infinity, and if you just left shift by t1, then this will also go till t tends to infinity. But do you need that? No, right? At t is equal to 0, we are getting some other equation that we have already written. So this is this equation from t is equal to 0, because u of t is there. So it is from t greater than 0. You will get this one. But if you add this one, then you are adding this one also. This 80 is also there till t tends to infinity. But we don't want that. We have to subtract this magnitude from t greater than 0. That's it. So you have to do minus 80 u of t. If you subtract this one, this 80 from t greater than 0 will be subtracted from this part, then you will get this remaining part. That's it. So this is how this equation looks like. And do we have any other equations that we have written? This is from t greater than 0. I think one we have written for t less than 0. See this one, it is going to 0, and so t for this equation for t greater than 0 it is always 0, and we have written this equation also, so no need to do anything for this equation, it is correct. And yeah, look at here, 100 e power minus t by tau 2 u of t is this equation, right? And we have 100 into 1 minus e power minus t plus t1 by tau 1 u of t plus t1. So this will just tell you it is left shifted. So this includes 100 is going, this 100 is there for t greater than 0 also, but you don't need that. You have to make the magnitude as 0 for t greater than 0. So 100 u of t. So if you subtract, then you will get only this graph, and if you add this equation to this one, then you will get the complete equation. Yeah, that is how this right shift and left shift will work in our concepts. So that is why I have discussed here, and let us move from here and solve some more first order circuits. Yeah, we will take this circuit first. Okay, so given this circuit, you have to find IL of t, Vc of t, and find tau 1 by tau 2. Tau 1 and tau 2 are two different time constants here. So is this first order circuit or second order circuit? If you look at here, we have one inductor and one capacitor. So it looks like it is second order circuit. But if you analyze this circuit and if you think, then you will get to know that this is a simple first order circuit. That's it. So why? Let's say you have applied from t greater than 0 only, just not to confuse. So we have 20 volt from t greater than 0, and these two are in parallel, one RL and one RC. So what will happen at t is equal to 0 plus? The capacitor will be short circuited because it does not allow sudden change of voltage, and the inductor will be open circuited because initial current is 0. So this is 20 volt and this is open circuited. And this is short circuit. So what is the current flow through the capacitor at t is equal to 0 plus, which is 20 amps? And what is the voltage across the inductor at t is equal to 0 plus, which is 20 volts? Because there is no current through this branch, so the drop is 0. So this voltage is 20 volts. So if 20 amps of current is flowing through the capacitor, then the capacitor starts charging. Similarly, if there is some finite voltage across inductor, then the inductor starts charging. So let's say at some time t is equal to t1, let's say it is charged to 1 volt and the inductor is charged to 1 amp, let's say. So let's say this is 1 volt and this is some current at t is equal to t1. Now depends on this voltage charged, which is 1 volt, and here it is 20 volt. There is some current flow of 19 amps now, right? So this 19 amps is still positive and it is flowing through the capacitor. So this will further charge, but compared to the previous one, this will slowly charge. So the capacitor will charge like this, and the same concept applies to the inductor current also. So depends on this current, there will be some voltage drop here. So depends on this voltage drop, you will get some voltage across the inductor which will be less compared to the previous one. So if you take it is 1 amp, then this is 2 ohms, so you will get 2 volt drop, then you will get 18 volt here. So this 18 volt is less compared to the previous 20 volt, so still it is positive. So the inductor will keeps on charging, but the charging time will be less compared to the previous one. So are these two are charging independently? So if I take separately, I have 20 u of t and let's say I have this circuit and this circuit. So if you look at here, at t is equal to 0 plus, this will be short circuited and you will get the 20 amps of current, which is same as in our case also, you are getting 20 amps of current. And since 20 amps of current is flowing through the capacitor, let's say after some time it is charged to 1 volt, and if it is charged to 1 volt, how much current you will get? 19 amps. So depends on this charging current only, this will be, the voltage will be built up across the capacitor. So that is how we are also getting in the circuit also. And similarly for inductor also. So at starting it is 0, so you will get 20 volts, right, at starting, and depends on this 20 volts, this starts charging, so it will charge to some current, and depends on this current, you will get some drop here and this voltage will be reduced to 18 volts. That is what we are also getting here. It means this charging current of the inductor and the charging voltage of the capacitor are only depending on the input voltage, not on each other, right? So this is not depending on this capacitor voltage, and this capacitor voltage charging is not depending on this current. They are two independent circuits, looks like. So these two will charge separately, independent of each other. That is how this circuit will work. So you will get exponential equations only, like we have got in our first order circuits. So that is what I have to explain here. So if you draw voltage across the capacitor Vc of t with respect to time. At starting it is 0 and 20 amps of current will flow. So it will be charged to some voltage and 19 amps of current will flow and it will be charged to some other voltage, and this slope will be reduced, so you will get exponential waveform, same as first order circuit, and this will be charged completely to 20 volts, right? So at t tends to infinity, the inductor will be short circuited and capacitor will be open circuited. So you will get 20 volts, so it is completely charged to 20 volts. Even if you have only 20 volts and you have series RC, it will be the same case, and here also it will be charged to 10 amps. So these are the steady state conditions. Yes. So this is 20 volts. And this is 10 amps. So this is 20 times 1 minus e power minus t by tau 1 u of t, and this is 10 times 1 minus e power minus t by tau 2 u of t. So what is tau 1? R equivalent times C equivalent, which is 1 second, and tau 2 is L by R, which is 1 by 4 seconds. So it means the capacitor charging is taking more time to reach to steady state, and which is less for inductor. So this will charge very fast compared to this charging of capacitor. So you can find tau 1 by tau 2, and we have drawn IL of t and VC of t. And in last lecture, if you remember this dependent current source circuit, right? Actually here you have to find I of t for t greater than 0, but we have found Vc of t for t greater than 0. That is true. I mean, we have to find initially the voltage across the capacitor only, then only from there. So since it is first order circuit, my suggestion is to find first the voltage across the capacitor. Whatever the current or whatever the voltage is given to find in the question, doesn't matter. You have to find the voltage from there, because this is simpler, right? We have already some known equation, which is final value plus initial minus final into e power minus t by tau. That is known. So if you find that voltage across the capacitor or current through the inductor, then it is easier to find any other voltage or current in the first order circuit. So we have already found Vc of t. Now you just have to find I of t. So I of t is just by doing some circuit analysis, you will get that. So let's do here. So for t less than 0, at t is equal to 0, the switch is opening. So at t less than 0, we have 100 volt. So you have VC of t, right? I think better if you so I will derive the I of t now. Now assume, not assume, we have already know this. So VC of t is already known, right? So for t less than 0, we have 100 volt, 2 ohms, VC of t I by 2, 4 ohms I, and you have to find I of t. So since this is VC of t, we also know IC of t, because IC of t is C times dVC of t by dt. So you know IC of t, and if it is VC of t, then just simply apply nodal analysis here. So what is this current? This current is VC of t minus 100 by 2 ohms. So if you apply KCL at this node, then this is leaving current, which is VC of t minus 100 by 2, plus this is also leaving IC of t, and this is entering, so minus I of t by 2, and this is leaving plus I of t, which is 0. So from this you can get I of t. So IC of t is known, which is C dV by dt, and we know already VC of t. So you will get this I of t equation. And for t greater than 0, we don't have this left side source, right? So it is simply this IC of t I by 2, I of t so if I by 2 current is coming from this branch and the total I of t is flowing through this branch, then there should be I of t by 2 should come from this branch, right? Then only the KCL is valid. So if this should be I of t by 2, then IC of t is minus I of t by 2, right? Because these two are in opposite directions. So simply I of t is minus 2 IC of t. So if you solve, then you will get for t less than 0, and I of t is minus 2 C dV by dt. Then if you solve this, you will get for t greater than 0. So this is brief circuit analysis of this circuit. See, you may get some doubt here. For t greater than 0, this is Vc of t, right? So which has some initial voltage. Let's say it is 80 volt. If I remember, it is charged to 80 volts. So for t greater than 0, since we don't have any independent sources here, the capacitor voltage will be completely discharged. So if it is completely discharged, the current has to come out of the positive plate of the capacitor. So if you have the capacitor here, let's say, which is charged to 80 volts, and we have some circuit here which is without any independent voltage or current source. So let's say it is represented by some R equivalent. Now this will be completely charged through the resistor and this will become 0. That is how this circuit is working. But why IC of t is in this direction? This is discharging in this direction, right? Which means in this direction I should get I of t like this. Finally I of t will go to 0. Initially it is 80 by R equivalent. So but why am I taking in this direction? So in general, if this is capacitor voltage, you have to take the capacitor current in this direction into the positive plate of the capacitor. But we are getting opposite here, right? That will be explained here. So Vc of t is e power minus t by tau, right? So if you do c dv by dt, then you will get minus, right? So which is minus 80 by tau e power minus t by tau, which is negative. So it means this is nothing but IC of t. So IC of t is negative, which means this current is negative, which means the current is flowing in this direction. So this is positive. So that is, you have to remember, you have to take, if you are doing some math, then you have to take IC of t in this direction only. Or if you know the logic, then you apply the logic and do the sign change after that. That's your choice. So in general, better way is to take IC of t in this direction. Yeah. So we can solve that circuit. This is a simple first order RL circuit. You have only one inductor and there is some equivalent resistance. So at t is equal to 0, this switch is opened. So for t less than 0, the switch was closed, which means there is no meaning of 3 ohms parallel to that short circuit, right? Since the complete current will flow through that short circuit path. So you have 10 volts and 2 ohm, then short circuit, then inductor. So let's say IL of t, you have 10 volts completely. So you might have applied at some point, right? So let's say you have applied at minus t1 and at 0, this is the switch is open and this 10 volts is there till t tends to infinity. So the inductor starts charging from minus t1 and this will be charged to some current and it will stay at that current. So this is 10 volt and this just for reference. And what about this final current? If this is short circuited, then you will get 10 by 2, which is 5 amps. So I'm writing directly, I'm not going to draw the circuit again. And after this one, t greater than 0, the switch is open and you have 2 ohms, 3 ohms and inductor. So what is the final value of the circuit? Which is 10 by 5. The inductor will be short circuited, which is 2 amps. So this will be discharged to 2 amps. And this will stay forever. And finally this will be short circuit and the 2 amps will be there till t tends to infinity. If you want to write mathematical equation for this, then we know, right? We know this equation, which is, let's say this is right shifted now, and we know this equation, which is 5 times 1 minus e power minus t by tau. And yeah, that time constants might be different in these two cases. So here, what is tau 1? Which is L by R equivalent. R equivalent is, if you short circuit this 10 volts, then you will get 1 by 2. So tau 2 is, L equivalent is 1 and R equivalent is 5. Just short circuit this one. So this will reach to steady state in 5 time constants, and this will reach to steady state in the sense from 5 amps to 2 amps in 5 tau 2, which is 1 second, right? So I'm saying, if you left shift here this graph by t1, then you will get this kind of graph, which is always there for t greater than 0 also. But here we are getting some different graph, right, for t greater than 0. So you have to make this magnitude as 0. Then only it means you have to subtract this 5 u of t, because this magnitude is 5. So if you subtract this 5 u of t, then you will get this graph, right? So if you simply left shift, then you will get 5 times 1 minus e power minus t plus t1 by tau 1. This is tau 1 and this is u of t plus t1, and you have to make this magnitude 0, right? Since this is not like this, right? And if it is like this, then this will be add up and you will get steady state as 7 amps, which is not true. So if you do that, then you will get, I'm directly writing IL of t, you will get 5 times 1 minus e power minus t plus t1 by tau 1 u of t plus t1 minus 5 u of t. This is this equation. And what about this equation? Plus, which is there for t greater than 0. So you write this equation and multiply with u of t. You will get that equation. So final value plus initial minus final times e power minus t by tau 2 u of t. So this is the complete inductor current equation. And ignore the equation, you intuitively you have to draw this graph. That is the main objective of this course. So that is how this circuit will work, and you will get the current through the inductor. Now let's solve this circuit. So look at the circuit. At t greater than 0, the switch is closed, which means this is open for t less than 0. So for t less than 0, you have 300 volts and these two are in series. So 1 by 2 Henry, 10 ohm, 30 ohm, 30 ohm. So you have to find V of t for this circuit. So this is a first order RL circuit. So I told you have to find first the current through the inductor. So let's find that. So from that you can get any variable. So this is IL of t. So for t less than 0, we have 300 volts is applying. So at steady state, this will be short circuited. So if it is short circuited, then at steady state 300 60 ohms, 10 ohms, right? So you will get 30 amps, 300 by 10. So you will get 30 amps of current. So this will be charged to 30 amps. So again, let's say this is IL of t. So minus t1, and from 0 to this will be charged to 30 amps in 5 time constants. So from here to here it is 5 time constants, which is minus t1 plus 5 tau 1, and tau 1 is R equivalent by L equivalent. So if you want to find R equivalent between these two terminals, then you short circuit this one, then there is no this will be ignored, right? So since it is short circuited and it is across the short circuit, so ignore this one, then you will get only this 10 ohms. So I'm directly writing tau 1 is R equivalent of 1 by 2 by 10, which is 1 by 20 seconds. So this is tau 1. So this is minus t1 plus 1 by 4, since tau 1 is 1 by 20, and at t is equal to 0, it is short circuited, that path. So for t greater than 0, we have 300 volt, 30 ohms, 30 ohms, and short circuit, and 10 ohms inductor. So this is the circuit for t greater than 0, and inductor value is 1 by 2. Okay, So at steady state this will be short circuited, right? So at steady state if you draw, then this is completely short circuited path. So if this is short circuited across these two terminals, right, we have this short circuit. If it is 0, then this is also 0. So it means this will be ignored since it is across the short circuit. And we have 30 ohms, and this node is same as this node, right? So this terminal and this terminal are same, and we don't have this resistor now. So if across two terminals we have two resistors, then those two resistors are in parallel. So I am saying this is 300 volt. So if it is 0, then this is 0 volt. I am taking this as reference, which is ground. So this is 0 and this is also 0 volt. So okay, ignore this one. You have to find the short circuited current, right? So that is at steady state, which is IL of infinity. So these two resistors are in parallel. So you will get 300 volt and this 10 parallel 30, which is 10 into 30 by 40. So 30 by 4, 15 by 2, 7.5. So 7.5 ohms, and inductor is short circuited at steady state. So simply IL of infinity is 300 by 7.5. So 300 by 15 by 2, which is 40 amps. Yeah. So finally from 30 to this will charge to 40 amps and it will stay at 40 amps. So this is for t greater than 0, and for t greater than 0 you should assume the initial current as 30 amps, because that is what we got this steady state current for t less than 0, right? So you have to take that as initial current as 30 amps and you have to write this equation. So if you want to write the equation, then so for this part this is 30 times 1 minus e power minus t by tau 1. Okay, we did not find tau to write. So what is the time constant of this circuit? So if you want to find the resistor equivalent resistance across these two inductor terminals, then so short circuit this one. Okay, let's find that. So for tau 2 you have to find R equivalent. L equivalent is 1 by 2 Henry, and between these two terminals you have to find R equivalent. So short circuit the voltage source, which is independent voltage source, and 30 10 these two terminals. This is ignored, and this you will get similarly as, okay, you have short circuit here. Okay, so we are finding for t greater than 0, right? So the switch is closed and you have short circuit. So this terminal and this terminal are same, right? So because this is directly connected and this is short circuit, and you have this terminal, let's say this is A and this is B, this is also B. If this is A, then this is also A and this is also B. So if you find R equivalent across A and B, which is nothing but across A and B you have this resistor, and across A and B again you have this resistor, and this is also across A and B. So R equivalent is simply, which is R equivalent to, let's say, is parallel combination of all three resistors, which is 30, 30 and 10. So if you find R equivalent, if 30 and 30 are in parallel, then you will get 15. If 15 and 10 are parallel, then you will get 15 times 10 by 25. So 3, 5, 2, 6 ohms. So tau 2 is L by R, which is 1 by 12 seconds. That is tau 2. So this will be charged to 40 amps at steady state after 5 times of tau 2 seconds. So this is about that circuit. So you have to find V of t now. So V of t is simply, did we write this equation? No. So 30 times, so I am writing this equation, which is, if it is there, if this equation is there, I mean this waveform is there from t is equal to 0, then you will get 30 times 1 minus e power minus t by tau u of t. But this is left shifted, and also that there is no 30 amps of magnitude after t greater than 0. So first you have to left shift that one, which is minus of t plus t1 by tau 1 u of t plus t1, and you subtract 30 amps for t greater than 0. So you got this one now, plus this equation, final value plus initial value minus final value times e power minus t by tau 2, because it is there from t is equal to t greater than 0, and times u of t. So this is IL of t. So if this is IL of t, then V of t you will get simply L di by dt. That's it. So VL of t is L di by dt. Yeah. And we will solve these three circuits. Yeah, we will solve. So for t less than 0, at t is equal to 0, the switch is moved from position A to B. So for t less than 0, we have only one independent voltage source, and for t greater than 0, this is moved and we have one independent current source. So at both the cases, it is simply a first order circuit. So for t less than 0, we have this circuit. So at steady state, the capacitor will be open circuited. So you will get 100 volts, 2 ohms, 2 ohms. and the capacitor will be open circuited. So you will get V of infinity as 100 by 2, which is 50 volts. So that is at t less than 0, and tau 1 is R equivalent. R equivalent is short circuit this one, then these two resistors are in parallel. If you look at from these two terminals, so you will get 1 ohm. So 1 into 0.1, which is 0.1 seconds. So that is tau 1. And for t greater than 0, you have this capacitor and with initial voltage of t volt and 3 ohms, 2 ohms, 5 amps. So for t greater than 0, the time constant is from these two terminals. So the cap value is 0.1, and R equivalent is you open circuit this current source, then these two are in series, which is 5, which is 0.5 seconds. And the steady state value is at steady state. This steady state and this steady state are different, so that we already know it. So for this is for t less than 0. It doesn't know that some transient behavior is coming at t is equal to 0. So it will assume I have to reach to 50 volt. So towards 50 volt, this starts charging. That is what the steady state meaning here. And here at steady state, it will be open circuited. I'm directly writing this will be open circuited. So there is no current flow further. So if there is no current flow, then this complete 5 amps will flow in this direction. So you will get the voltage across this 2 ohms resistor like this. So which is same as the voltage across the capacitor. See, this is open circuited at steady state, and this is 2 ohms, and this is 5 amps. So you will get 10 volt here, because this current is 0 amps and there is no voltage drop. So this voltage is nothing but, so I am taking this as Vc of t. So this Vc of infinity is same as this voltage, right? Since it is 0 but in negative polarity. So Vc of infinity is minus 10 volt, which means it is charged in this direction. So yeah, if we draw, then this is Vc of t. So let's say this is from minus t1, this is charged to 50 volt in 5 time constants. This is 50 volt, and from 50 to minus 10 volt, this is charged again. So from here, this is not discharging, this is charging in reverse direction. So after some time, this will go to 0, and this will charge to minus 10 volt, and this will stay here, because there is no transient behavior further, and this is the steady state value. So this is minus 10 volt, and this won't take 5 time constants because yeah, because the initial voltage is 50 volt, not 0 volt, and this is independent. This is again, we have one independent current source, so this is charged to minus 10 volt without, with some initial voltage of 50 volt. So if you want to find this steady state, how much time will it take to reach steady state, then you can find from the equation. So this equation is minus 10 plus 60 e power minus t by tau 2 u of t, and you can also write this equation, which is 50 times 1 minus e power t plus t1 by tau 1 u of t plus t1 minus 50 u of t. So just add these two equations, then you will get Vc of t. So if you want to find the steady state time from t is equal to 0, after what time will it reach to steady state, then you simply find at what time this will reach to 99% of its final value, let's say minus 0.99. So solve this equation, then you will get one time, that is the steady state time. So that is fine. And charge transferred from 25 microseconds to 100 microseconds. So we know that the charge Q is equal to CV, right? So Q is equal to CV. C is constant, which is 5 microfarad. And let's say if you want to find Q of t, which is at any time, then you have to multiply the voltage across the capacitor at that time. So which is 5 micro times V of t. So V of t, which has initial voltage of 10 volt, and this is a simple first order circuit, and this will be completely discharged to 0. So which is e power minus t by tau. E power minus t by tau is 5 micro into 5 u of t. So from 25 microseconds, Q of, let's say it is t1, or t is equal to 25 microsecond, then you will get 5 micro times 10 power e power minus 25 micro by 25 micro. See, you don't have to solve for this one, because 25 microseconds is nothing but the time constant, right? So the time constant is RC, which is 25 microsecond. So what will happen at time constant? The capacitor voltage will discharge to 36.6% of its initial value. So if you directly write 36.6% of initial value, then 0.366 times 10, which is 3.66 volts. This is the V of t is equal to 25 microsecond, 3.66 volts. So let's say it is Q1. Q1 is 5 micro times 3.66 coulombs. You will get Q1. And for Q2, 5 micro times, you have to find the voltage at 100 microseconds. So if you take 5 time constants, which is 125 microseconds, so at 100 microseconds, definitely it is not reached to steady state, so there will be some voltage. So you have to find that voltage, which is 100 micro by 25 micro. So 5 micro times y10 power, this is 10 e power 100 micro by 25 micro, so 50 micro times e power minus 4 coulombs. So the charge transfer will be from one point to other point is q2 minus q1. So let's solve this circuit. It has one dependent voltage source which is dependent on the current through the inductor, and we have one independent voltage source, and we have one inductor. So this is simply a first order RL circuit, and you have to find I of t. So Ix, what is Ix? Ix is not mentioned here, so I will double check this one and we will solve this circuit in next class. So if you like this video, please share with your friends, and if you have any doubts, please comment down. So from next class we will try to solve more complex circuits. Let's say, what if the capacitor voltage changes suddenly, and when will the capacitor voltage change suddenly? If it has to change suddenly, then how much current has to be flown through that, has to flow through that capacitor, then all that theory, and we will try to cover more problems. So this is about today's lecture, and if you have any doubts, please comment down. Yeah, thank you.